Hello, my name is Cole Francis, and this is my lab report video for Physics 2212 Modern Lab 4. So as far as the overview and purpose of the lab go, basically the point of the lab was to predict behaviors of circuits containing resistors in series and in parallel, to use multimeters to measure the values of current potential difference in a circuit, and to examine the behavior of resistors and capacitors in circuits. So for this lab, the materials were pretty easy. It was just an online circuit construction kit, which we used to build the different circuits we need to use to run the experiments. The physics principles relevant for this lab were Ohm's law, which is that the current equals the potential difference over the resistance for components in a circuit and as for the circuit as a whole, and capacitance, which is where capacitance equals charge over the potential difference across the capacitor. The node rule, which is that the total current entering a node equals the total current leaving the node. And the loop rule, which is that the voltage around, or the potential difference around a closed loop in any circuit is 0. So for the initial setup for this lab, I set up a circuit with two 1.5 volt batteries that were connected in series to two resistors, with the top resistor being 47 ohms and the bottom resistor being 100 ohms. We then took measurements of potential difference across each component of the circuit. As you can see here, across the battery, the potential difference was 3 volts. The potential difference across the first resistor was 0.96 volts. Potential difference across the second resistor was 2.04 volts. And the entire overall circuit current was 0.02 amps. Also, across all the other components, which include the wires and the ammeter, the potential difference was 0 because in this ideal simulation, none of those have any resistance. When the ammeters were in parallel with each other, the current in the parallel ammeter to the 100 ohm resistor went down from went up from 0.02 to 0.06. So you can see the actual resistance calculations for the two resistors, the wire and the ammeter, and you can see that the calculated resistance in the 47 ohm resistor was actually 48 ohms, and the calculated resistance for the 100 ohm resistor is 102 ohms, which are both slightly higher than the listed value on the resistor. As for the wire and the ammeter, both came out to be 0 ohms because there's 0 potential difference found across each of them, which show that in this simulation, neither had any resistance. So for the second computational model, with the capacitor in the battery and the light bulb, we used a 9-volt battery, a 200 millifarad capacitor, a 10 ohm bulb for this setup, and a 20 ohm bulb for another setup. And then using this setup, we discovered that current decreases exponentially over time, both when the capacitor is charging and when the battery is removed and the capacitor is allowed to discharge. The exact time we found that it took for the capacitor to charge was 6.11 seconds. The exact time we found for the capacitor to discharge was 5.96 seconds. So, using the data we got from that lab, the data we took from that lab is we found data for the change in voltage over time of the circuit, and you can see here that we plotted the time against the change in voltage of the change in voltage at each specific time over the initial potential difference across the battery, which was 9 volts. See, this led to a negatively proportional trend, and the slope of this line was then able to be used to find the capacitor time constant, RC. So RC in this case was equal to the magnitude of 1 over the slope of this line, the slope of this line being negative 0.7125. So doing 1 divided by that gave us 1.43 or 1.403, which is what the capacitor time constant was for the scenario. So now we're just the final reflection questions. If the lab were to be done in real life, the ammeter would have resistance, and its readings would therefore be lower than in the simulation. And also, the model would predict the capacitor to charge instantaneously because the wires and the ammeter and the capacitor all would have zero resistance. However, if this lab was done in real life, it would take some time to charge since all the components, the wires, the ammeter, the capacitors, would all have a small amount of resistance, but resistance nonetheless. Okay, thank you for watching this video, and I hope you learned a lot.